Welcome to HP Tuner's Ford Gen 1 Coyote Training Part 28. In this training module, we're going to take a look at dialing in our idle control within our Gen 1 Coyote engines. Now, we're going to find that the idle control is relatively straightforward to get sorted out, but we need to make sure we're logging specific channels in our VCM scanner and using specific histograms to repopulate our idle control tables. I'm going to go over the basics of idle control and then using our log data to be able to make appropriate changes in our idle control routine. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at programming our idle control within our Gen 1 Ford Coyote PCMs. Our idle control is relatively straightforward to work with and program. There are some specific tables we need to calibrate and make sure that are updated based on the modifications you have done. So if you've installed cams, if you've installed, let's say, a supercharger, that may start to alter what the base tables are going to be doing in terms of the closed loop feedback. So we're going to break down how this works, what tables need to adjust, and then paying attention to log data, what to look for, how to log the data properly, using the histogram log data to be able to populate and fix any kind of errors in our idle control routine. So let's jump in here and let's talk about the basics first, then we'll move into talking about how the programming fits together and then move into our log data examples at the very end here. So the first thing I have open, I have a VCT tuning file open. This is a 2013-14 Mustang GT example file. This is what we've been using in several other videos in our training tutorial, kind of building off of this specific file as we have went along in the process here. So it doesn't really matter which file you have open, any 2011 to 14 Mustang file will work as we're taking a look at the idle control routine. The idle control routine is going to be the same across the board for all of our applications here. Let's jump into engine and we're going to go from general into idle. And in idle here we can see we have a general tab, an RPM tab, airflow based tab, and torque. All of these fit together in order to make sure the idle control routine is going to function properly. Now, before we jump in and talk about the specifics of what we should change and what these tables mean, I want to talk about the basics, fundamentals of idle control, how it works, what we're trying to accomplish, so we can move forward into our tables here and understand what is actually going on, and then we can move into the VCM scanner again and take a look at some things so we can break this down even further. So the very first thing we need to cover here is the fundamentals. What does idle control, what is going on, what does idle control actually mean, and what are we manipulating in the actual, the engine's operation in order to hit a desired idle speed? So we'll find in idle control, in general terms, again, across pretty much any kind of engine, we're going to go and want to idle at a certain desired idle RPM target. So that might be 800 RPM, that might be 600 RPM, that might be 1000 RPM. When we're going in and telling a ECU to run at a certain idle target, we're telling the ECU that we want to have a certain level of engine torque to achieve that idle target. Now, we're not actually working in units of torque for idle control, we're working in just the units of RPM. So we want to go and idle at X RPM, but by telling the PCM that we want to idle at X RPM, we're essentially manipulating the engine's torque to reach that desired idle speed. So every engine will be different in terms of the torque output that it needs to hit a desired idle speed. We can utilize a couple different ways of the engine's combustion in order to get to that desired torque, in order to be at that desired target idle RPM with our idle conditions. So in order to vary the amount of torque output out of the engine, we can vary the amount of airflow, we can vary the amount of spark timing, and or we can vary the amount of fuel that we deliver to the engine. And when we're talking about idle and idle conditions, we're going to be at stoichiometric or 1.0 lambda target in our closed loop operation. So we'll assume that the fuel is taken out of the equation here because we're not going to be altering the fuel in terms of the target and what we deliver to the engine. We're going to be at a consistent amount of fuel being delivered. So we can essentially remove fuel as a means to alter the engine's torque production. But we do have airflow and spark timing, and that's what we need to lead into this understanding the relationship between those two and the idle torque to reach that desired idle speed. So when we're talking about kind of a coarse type of adjustment in our engine's torque production, that's going to be coming from the airflow. The airflow will drive up or down the amount of torque we produce in idle conditions pretty drastically. So if we're finding, in this case with a Gen 1 Ford Coyote PCM, we have drive-by-wire throttle control. We don't have an idle control motor that allows essentially a controlled vacuum leak externally through a solenoid. We're using the drive-by-wire electronic throttle plate movement to influence the amount of airflow coming into the engine under idle conditions. We let more air in, we'll find we drive up the engine's torque production and we'll have a higher idle speed. If we go and reduce the throttle plate movement, then we'll have less airflow, we have less torque, and we'll drive down the engine's idle speed. Now, depending on the size throttle body and depending on a lot of factors within the drive-by-wire control, we'll find that a very small amount of throttle plate movement leads to a relatively large change in airflow at idle conditions. Large airflow changes can lead to large torque changes, which can really have an influence and a jump on our desired engine RPM. So if we have, again, movement of the throttle plate, let's say 0.2% closed or 0.2% open, that can be the difference of engine torque being at something like maybe 10 pound-feet of torque to something like 15, or dropping to something like 7 pound-feet of torque. The torque will be very finite in terms of the torque we need to reach a certain desired idle RPM, and we need to make sure we're careful with how we're adjusting.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.